Welcome everyone, and thank you for joining the AMWA webinar with the short and sharp title, Cut Your IP Troubleshooting Time with NMOS BCP-008 Traffic Lighting System. Wow, I know it's a mouthful, but I'm sure many people will get intrigued or got intrigued by just reading the first part, Cut Your IP Troubleshooting Time. Nevertheless, there are so many tools out there, it's still not very easy to do the troubleshooting in a 2110 environment. But today we have an expert with us, Stefan Ledergerber, and he will discuss a cool new feature from NMOS. And NMOS can help you. And spoiler alert, at the end we will have a demonstration. But maybe first, Stefan, can you tell the crowd who are you?
Welcome everyone. I'm very glad to be here. I'm Stefan Ledergerber, so that's the proper pronouncing. I used to, I have a background in engineering. I was heading R&D both at Studio Soundcraft and later on Labo. And during that time, during developing IP stuff, I recognized the need for bridging manufacturers and users somehow together. So we founded Simplexity, a combination of, make complex stuff simple, as a company for training and consulting on IP projects about 9 years ago. And we are independent from manufacturers. So we just like to learn, gather experience from different projects and to kind of be a platform for other clients. So as part of this, we were happy to work for the Swiss Radio and Television, SRF, and we will probably talk later about it, but that's how I ended up as a product owner of an initiative called Minimum Status Reporting, also known as BCP-008 by NMOS and by AMWA. So that's me.
Wow, that's cool. So actually working at a real facility means you know the problem. So what is the problem that this tries to fix actually?
Well, everyone compares still IP and SDI central routers or audio routers. And I think the most significant difference between a central routing matrix and now with IP is before you had one unit you talk to and it would make you the connection from X to Y. And now this central unit from one manufacturer has actually turned into a distributed system made up by many different manufacturers. So now, in order to make one signal connection, you have multiple manufacturers who need to be talking to each other, and only if they do, you get your working signal. So this is, first of all, a much more complex task. But this actually, this establishing the connection is what NMOS ISO 4 and 5 is there for, and it's quite established, so that's cool. But now, since it's not just one box, we need to monitor those signals, the streams, from A to Z. And that means involving the edge devices from the different manufacturers. And we want that to be automatic. And that's basically the task here.
Wow. I'm immediately thinking about some of my IT friends who will say, oh, Wireshark is your best friend. But probably not when you're live on air and something goes horribly wrong. And unless you have supernatural capabilities of reading out thousands and thousands of IP packets per second. But there are specialized tools out there like Telestream, Bridge, Fabrics, Leader, and what have you not. But do we still need something else on top of this?
I think yes. The point is, these analyzers, they're great for what they do. They analyze problems and you somehow need to connect them and then you probably see stuff there quite intuitively. But the point is, they themselves are part of your distributed system. So they are not just like, sending a signal to one of these analyzers is actually already changing your system. And just because your analyzer says, I got sync, or I can decode that stream, doesn't mean that your actual end products, the receivers, for instance, have sync and can actually decode a signal. So there's quite a difference between the analyzer, where it's connected to, and your actual edge devices. So ideally, you want to get much closer to the edge devices, to the nodes who actually receive or send signals. And ideally, you put the probe right in there. And that's exactly what we try to do with BCP-008. We basically want to collect the information from the edge device because they already have it. They know whether they have sync. They know whether they can get something out of the stream and so on. So we just need to collect that information, which is already there in a standardized way.
Yeah, I see. And when you have a fantastic analyzer tool, you of course go with the tool towards where you think the problem is. So you need to know things that you don't know actually. So okay, this is getting interesting. So um, this was probably not created because some engineers had fun building it. I understand now. Because there was an actual problem, and since you said you worked at SRF, or with SRF on this problem. Are you able to disclose a little bit of the fun facts why this came to life?
Absolutely, yes, sure. You know, it's probably no secret that, and it's probably not unique to this project, that you have to meet deadlines. And if you risk to not meet them, you need to cut down stuff so you get on air. And what's one of these topics which are cut out will always be monitoring. So in this project, we had we decided to make a phase 2 of the project, which then covers the monitoring side. And so we first had to get on air. And in this project, we had 17 different vendors connected in one single network. And once we were on air, we were basically discussing with these vendors, how can we actually collect telemetry and data and status information from all your products? And we instantly found out this is going to be far too much complex to do. We had lots of dreams, but we had to cut them down. So basically, we were reducing to the max, and we said, what do we really need to know so the people in the MCR can actually know who to call? So they don't need to be the expert, but at least they can kind of locate the problem and know who to call. And on top of that, we said, we can't pay for 17 driver developments doing all of that. We don't have the time, we don't have the money, budgets are getting cut. So basically, we said this should be standardized. Like ISO 4 and 5, there should be a monitoring standardization. And that's when the AMWA stepped in and they said, let's do that. And so that's what turned into minimum status reporting, BCP-008. And I was basically acting as a product owner on behalf of Swiss Radio and Television.
Yeah, and for those who don't know, SRF, based in Zurich, it was one of the 3 what I call major new buildings throughout Europe. If I count CBC now as part of it. So there was CBC, there was BBC in Wales, in Cardiff, and SRF in Zurich. So they were one of the first, so probably they had to work through a lot. So I can see now where it's coming from. But it reminds me a little bit like back in the days working with alarm systems. It's very interesting when you move into the realms of IT, like moving from tapes to files. It gives an instant idea like, oh, now we can work with tools like, I do remember Nagios back in the days, a free open source tool to pull in alarms. But suddenly, if you have too many alarms on a dashboard, it looks like a Christmas tree. And well, at the end, nobody's going to look at it, even if there's a very important alarm, right?
Absolutely. I mean, basically, the thing with alarms is either you miss them, you don't have enough, or you have too many. And it's very difficult to find a middle way there. So both ways are bad. And if you have too many, you can always basically justify, well, it was written on the screen, but it doesn't help if people don't basically learn to ignore the screen. And I think many large monitoring systems could actually filter alarms in a meaningful way, but the configuration to do that actually is quite extensive again. So in real life, I've seen a lot of monitoring systems never being truly finished in the setup. And so basically, as a result, the users, are not really benefit as much as they could. So with BCP-008, we reduce to the max. And we make sure that the messages you get from the edge devices, from the senders and receivers actually, are so narrowed down that you can put it right in the user interface of an actual operator. So they don't have to be technical people. The idea is basically to have a little green light or yellow light or red light or whatever right in the switching UI of where they operate day by day, and that will already tell them whether things are okay or whether there's a problem.
Okay, so it can actually serve the purpose of users to more or less understand what's going on with the system. And if it's very simple, like a red or a green light or an orange light, they know when to call second line. So that probably helps a little bit. So would this help also be to have proactive alarms? Because at some point with IT, let's say if one power supply goes down, it's already good to know, right?
Yeah, of course. I mean, you don't want to know once the second one goes down. So yes, absolutely. So let me tell you a little bit about the concept of BCP-008. I already used the term traffic light. As a matter of fact, that's just a synonym. We just kind of refer to it, but actually the status we get are called healthy, partially healthy, and unhealthy, relating to green, yellow, red, right, basically. And the rules we defined are open and strict at the same time. So that means when is something yellow, when is it red? Basically, in practical life, we mean if you see green, of course, we're all happy. If it's yellow, it means you should probably check something or call someone during your next break. And if it's red, you're actually missing signal right now, so you should act immediately. But let me actually share a quick drawing of this. So that says more than 1,000 words. Hope that's working.
Yes. Yeah.
So basically, what we are very strict on is healthy means the services are okay, but there's no irregularities. And so what is an irregularity or not? That's dependent on the product and on the manufacturer to decide. And yellow means there is some irregularities, but you're totally okay. So, taking a -7 system with A and B network, you still have one link up. So you get all the packets and you don't have to worry for now. But yes, you should check the other link, right? And obviously red, unhealthy, means you do have a problem. So that's the concept. But when you pick which state, that's very much left open as long as you follow these rules. So that's basically the idea of it.
It reminds me a little bit of back in the days when we started to have networks in, let's say, nonlinear editing, and we said, oh, it should be redundant. And yes, you can build redundant networks. And then the moment it fails, this is the moment when you actually noted that probably the A path already was gone. So actually you guys thought about it and made sure this is already in the system. That's so cool.
Yeah, and I mean, sorry to interrupt there, but basically we don't tell whether a particular product can report packet loss on A and B networks separately. If it can't do that, then okay, that's the way it is. But if we can, we tell them, we give them a place to report this.
Yeah. The other thing which is interesting, and it's probably a concept the IT guys don't use, is no light. Because everything in IT should always be up and running. And of course, when we're talking about media production, sometimes, well, it's there, but you're not using it, right? So this is also part of the whole BCP-008. That's so cool. I'll quickly check if there are any questions in the chat already, and please feel free to pop questions in the chat. We're open to try to answer as much as possible. There was a concept, Stefan, about stream validation, packet synchronization, connectivity. Can you elaborate a little bit on this one?
Yeah. Well, I already mentioned we needed to reduce to the max. So we needed to decide what are the important topics which make a system run or break. So basically, we came up with 3 different topics. One is connectivity, is it okay or not? Second one is synchronization. Do you have sync, yes or no? And the third one is kind of stream level. Can you decode the stream and whatever? So those are the 3, let's say, levels which every edge device or every central receiver basically needs to report something. And basically we make then traffic lights for each domain. And actually on connectivity, we have two. And then we actually summarize those, what we call reporting domains, into an overall traffic light, which always takes the worst of the members. And that overall traffic light can be indicated and mapped directly to the user interface of a user. I will show you that later, but just to go into the to show you what I just meant again on a little slide. Basically you see this overall status, which is a traffic light which you can just show the user at all times. But then the domains are basically connectivity, meaning do I have all physical links? And that means all links I expect. So in a -7, I need 2 links. In a not -7, I need only 1. And packet level means, do I have all the packets at the right time? So are they late? Are they lost? Whatever. And again, you can report that with counters and stuff like that if you can as a manufacturer, but you don't have to. You just basically need to put that traffic light in the correct state. In the synchronization, that is a very good example. We ask, do you have all the expected synchronization? So if a device only expects PTP on a network A, then it shows green. But if it expects PTP on A and B, and it only gets it on one, it may show yellow. And actually, it's so open that if you expect a black burst in parallel on top of that, you would go yellow if you miss that black burst. So that's just the very generic question: do you have everything you need? And then on the third one, we make a distinction between the receivers and the senders. The receiver, we ask, can you decode the stream? So that may be a format error. It may be maybe even on HDMI type transmissions in the future that you don't have the key to decode it. Or on the sender side, then obviously the sender can't say whether you can decode the stream, but it can tell whether it has something to transmit. So do you have an essence to transmit? For instance, you could signal that you don't have a baseband signal. You have black, you have silence, or whatever. Again, if you can't detect that as a manufacturer, totally okay. You go green and that's it. It's down to your product to basically be able to report these things. We just tell you where and the rules. And one of the rules is the overall state has to take the worst state. So you can actually also add more states. You can extend these 4 traffic lights, 5, 6, 10 traffic lights, add another one for power supplies, totally fine. But the overall one would always take the worst of that. That's the golden rule. So that's what this is about.
That looks really, really excellent. And so Stefan, before returning to where I'm right now, I worked 5 years more or less in the operations department of a broadcaster. And my God, I would have loved to have this. So where are we? Can we buy it? Is it off the shelf available? Can I go to the store and just say, give me a BCP-008?
You should go and ask the question exactly. I mean, it's a chicken and egg thing right now, because what we see right now is that a lot of people say, yes, 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 I want this, I want this. And manufacturers obviously only implement stuff they get asked and can make business with. So right now, yes, we have a couple of vendors and we have an event coming up in Porto, for developers and stuff. There's quite a lot of activity there, and I'm actually also happy to show you a demo of some implementations here. But we need more of it, absolutely. And I encourage the end users to really ask for it, so the manufacturers realize there's something they should do, because it does add customer value. Absolutely.
Okay, I think you created the cliffhanger, so I think we're all ready to look at the demo. Too many questions, just viewing it or seeing it, that will probably be very good. So
sure.
I hope you're able to share it right now.
Absolutely. So you see a little GUI. It's basically a panel of a broadcasting system. In this case, it's Pebble. The top part is just like an example of a user panel, right? So what you see in front of the user. You see that, right? You see the desk, the shared screen, I hope.
Yes, we do.
Good. On the lower part, this is just for me. I can simulate in a device and senders and receivers some faults, so they're not actually happening. What I do is I have a sender here and I have a receiver, and I connect them together, and they're connected. So you see the little green light, which already says I'm happy. Cool. So this is what gives me confidence as a user. And now I actually introduce a little problem on the receiver side. For instance, I say you just lose a link. So I say nick one down. And if that's happening, I see the yellow state because it still has a second one, right? It still has a second link, so it's only yellow. Now, I know there's something I need to look at, and in this UI, I'm actually able to click that magnifier glass, and now we see those 4 domain traffic lights, as we call them, and 3 of them are actually yellow because something happened to them in this case. So we have a nick one down, which is fair. You know, I've got packet loss on nick one, and I've got apparently also no sync anymore in nick one, which is all explainable. And in this case, you see that every traffic light has an information, a message field. And we don't tell the manufacturers what to put in there. We just give them examples and encourage them to put in, meaningful messages. On top of that, we have a counter. Those counters actually increase with every incident you had. And they normally stay and, give you a little history indication. Because obviously it's still down to the control systems to log the messages, but this is a little indication in the edge device right away. What we also see is the overview state also carries the message of the most important domain, which in this case is connectivity. The link is missing, so the others are a consequence out of that. But let me show you, we have also, for instance, very practical rules. If I now repair the whole thing again, and I go to healthy, it will take 3 seconds to go back to green. It doesn't just switch back. We call it a reporting delay, and it's there to avoid flapping, of the states. Let me press in 3, 2, 1 now. So it's now repaired, and 3 seconds later, it turns green. We also encourage manufacturers to not just clear the message, but just add, basically prepend the word previously. So when you're back, in the green, and you see there's a little counter, something happened, you still can check in there and say, previously that's what happened. It's kind of a one-step, if you want one-step log, that's it. It doesn't take much on the edge device. We think we have really narrowed down the implementation effort, and stuff like counters, they're there, basically optionally. People can implement them or not, but that's down to them.
And can you explain? Sorry to interrupt, Stefan. Can you explain a little bit the delay more? Because I remember when in an IP network, I don't know if it's an official term, but our colleagues, they said, the OSPF is flapping, meaning it just jumps from the one to the other state. Exactly. Is this exactly why the delay is in there, just to minimize the amount of notifications you get, or how does it work?
Correct. You should not get okay, not okay, okay, not okay, and okay, not okay. Because if that's happening, it's not okay, right? So basically, that's exactly why we put that effort, that delay in there. Now, can you adjust it? Yes, you can. But the default in the spec says the default is 3 seconds because we consider that to be a meaningful default. So there must be that delay in there, and obviously only happens in one way, because in one direction, because if I go, let's say, all nick down in 3, 2, 1 now, it immediately goes red, of course, because that is a bad state. And if I now check in there, you see obviously everything being red. So as a default also, when we disconnect that receiver and I connect it again to somewhere else, that counter is reset to 0 because we assume that majority of users only care about the current connection. But this behavior can be changed. In case someone wants to keep that counter not resetting, you actually can, that's one of the minimum things we have left open. So you can say, no auto reset, please. And then it doesn't reset there. But just to give you also an indication on the sender side, we also have the 4 domains. The link is exactly the same as on the receiver. The synchronization exactly the same as on the receiver. But now we have a transmission error, which kind of is reserved for other technologies, not 2110, where you have maybe SRT or whatever, where you can actually get transmission errors and the sender knows about it. So he can actually indicate that here. And on the signal level, let's see what happens if I, for instance, disconnect SDI. It could tell me no signal on SDI in 3. It's red, and the overview state is also red because it's nothing to do with IP, but there is no signal on that connection because you just disconnected SDI, so it's as red as everything else.
You just mentioned another interesting thing, Stefan, because people always think when they hear or talk about NMOS, they immediately think it's 2110, but it's actually not just for 2110, right? So you can use this for SRT, you mentioned. Are there any others?
Yes, there is MPEG TS right now coming up. There is ideas about activities on H.264, 265. Basically, yeah, all kinds of stuff. So there's even thoughts about NDI. So NMOS just a control protocol for all these topics, and it was very, very necessary for 2110 in order to make it a success to start with. But it's very open, and not to forget the upcoming cloud initiatives and stuff like that, where we desperately need control standards for controlling shared memory processes and stuff like that. So that's the mission of NMOS.
Yeah, I'll look at the chat and see if there's any questions popping up. There are a few, but I'm gonna try to do an experiment. I don't know how many users there are on the call, and I don't know if they can post a reaction, but I would for sure know if they're interested in this. Imagine you would have got this. How much time would it have saved if you were troubleshooting your IP, your 2110 facility? I think it's amazing. But I'm just curious to see if there's any reaction in the chat about this. Oh, I already see thumbs up going. So if there are any vendors on the call, this is already a feeling you get that it's really interesting to implement this at some point. So people will be asking about it, I'm quite sure. But talking about implementations, we're at the early stages, I think so, right?
Mm-hmm.
Can you elaborate a little bit on this?
Well, basically, we need to kick this off. Everyone wants it, and we can either wait until you as users put it into your tenders, and that's going to be just long and slow. And I think we still believe on some visionary manufacturers who are just seeing the need for that. It's so apparent, right? I mean, ultimately, some people are not switching to IP because they are scared of that black hole of the network, and everything they experience is just, well, maybe it's the network and I'm lost. They don't feel in charge anymore with this new technology. And I think BCP-008 is a key. It can be a key for these people to actually adopt to IP in a big way, because if nothing else, it should get them confidence back that they are in charge again and they are mastering the signals. So basically, we need to kick this off. And in history, in many ways, it was plug fests and stuff like that we did, and checked basically. People come together and plug in stuff and get things going, and that's exactly what we are doing right now. End of November in Porto, you'll find the details. I'm sure Cindy will post them somewhere here. And we just encourage, mainly developers, come there, spend some time with interesting colleagues in a room, hack stuff, and basically, go there and see what's coming out. There's no prerequisites in terms of knowledge. We just see what's coming out in a week and what's possible. So I believe in that community approach, because it's a good thing, right? And we just need it.
That sounds so cool, Stefan. And so you just did a call out to the vendors. I'll do a call out to users, just saying, let's put the pressure on. This is something that we really need to have in order to make sure that we're running smooth operations. But I'm afraid we're already out of time. So let's see if we captured the questions. Maybe we can get back to you at some point with more answers. But for this, I would like to thank everybody for having joined us, and I hope it was informative. And well, let's make it happen. Thank you so much.